In this lecture, we will look at the operational amplifier based difference amplifier. This also is called as a differential amplifier. The circuit diagram of a differential amplifier is shown here. The difference amplifier has both inverting input as well as the non-inverting input. And the output voltage is because of both inverting as well as non-inverting inputs. In this particular example, I have got only one inverting and one non-inverting inputs. On the other hand, you might be having a lot of inverting inputs as well as non-inverting inputs. Well, in order to solve such problems, we can use the superposition theorem. So what we will do is, we will take one voltage source at a time, disable all the other voltage sources, find the response because of this particular voltage source. So the final response is summation of all the responses that are taken individual. What I mean to say is, you find out the output voltage because of V1, grounding V2, and find out the output voltage because of V2 by grounding the voltage source V1. Well, let us take only the first voltage source V1. Now, when you take only one voltage source, the other voltage sources are to be obviously grounded. So when I ground the voltage source V2, the operational amplifier circuit will look like this. Now, this looks like a simple inverting operational amplifier whose output Vout is given by minus Rf by R1 into V1. So this response, this particular response or output is because of only one voltage source V1. Now let us take the second voltage source V2. While we take the second voltage source, the first voltage source must be grounded. Now this is a simple non-inverting operational amplifier configuration. Well, the output voltage of this particular operational amplifier, taking this voltage V into consideration, the expression is the Vout is equals to 1 plus Rf by R1 into V, this voltage. Now what is the value of V? If you happen to see the value of V, it is nothing but the voltage across a voltage divider circuit. So V is nothing but Rg divided by R2 plus Rg into V2. Now substituting the value of V in this expression, you will get the output voltage because of only one voltage source V2, which is the non-inverting voltage source. Now the total output of this particular difference amplifier is because of both V1 as well as V2. Now combining these two expressions, you will get a lengthy expression like this, where Vout is now a function of both V1 as well as V2. Now what we will do is, we will assume that all the resistors values are same. Now if I make Rf is equals to R1 is equals to Rg, then the output voltage is nothing but V2 minus V1. So this is the output voltage expression for a simple difference amplifier. Thank you.